Hello everybody, today we will be going over a trigonometry problem at the IB Math Studies level. So we have sailing boat which has a sail in the shape of a right angle triangle, which is here, to give us the sides BC, the angle 76, and the angle 90 right here. So for part A, we need to calculate the height of Temi's sail. Now with any trigonometry problem, as I've always told you in the other examples, your plan A is going to use the sine rule. And the sine rule, just a quick reminder, works in pairs. You have a side paired with an angle, right? And so we go ahead and look at this exercise and see if we have any of those pairs. And we see that this angle here is paired to that side there, which we have both. And we have this side here paired, sorry, this angle here paired to that side here, which is AC, which is exactly what we need to find. And so, very conveniently, we have our two pairs here and we apply them. So the first pair is like this, 5.45 divided by sine 76 equals x divided by sine 90. And so we want to get x alone, and so it's very common to cross multiply here. X times sine 76 equals 5.45 times sine 90, right? And so to get x alone, we're going to divide both sides by sine 76. And so of course we end up with x being equal to this whole thing here, 5.45 times sine 90 divided by sine 76. And so we plug all of this into our calculator, and we end up with 5.61684 meters. And so that is for part A. And now for part B, they give us the information that William also has a sailing boat with a sail in the shape of a right angle triangle TRS, which is here. They give us the side RS and the area of William's sail, which is 10.7 meters squared. So we need to calculate RT, the height of William's sail. Now, of course, I can't tell you that I know exactly what to do here, but what I can tell you is that if they ever give you a piece of information, you know you're going to have to use it. And so the area of a triangle is base times height divided by 2. So right now we have the area, which is here. We have the base, which is here, which they gave to us earlier, and we would be missing the height. So effectively, we only end up with one variable. So we plug in, they'll put 10.7 for the area, the base is 2.8, and the height is just h, and it's all divided by 2. So we multiply both sides by 2 to get rid of the 2 down here, but more importantly to get h alone. We end up with 21.4 on the left side, equaling 2.8h. So we divide both sides by 2.8, and our calculator will give us the following. Finally, for part C, we will calculate the size of the angle RST, which is this one right here. And so right now, currently, if we go back to plan A, which is the plan of the pairs, this angle here is paired to that side there, so we're good in that sense. But this angle here, this side here is paired to that angle, which we're missing, and this angle here is paired to that side, which we are also missing. And so of course, there's many ways to solve this, but I suggest that you always use this sine rule when you can, just because getting comfortable with it with one way to solve problems is good, okay? Just to do things faster. And so we know that we can get the last side, which is this one here, by using Pythagoras theorem. So applying Pythagoras theorem here to find the side TS, we're going to have 7.64 squared plus 2.8 squared equals the side TS squared. And so putting this into our calculator, we end up with this number here. So the next step, of course, is to get rid of the squared. So we're going to do a square root to both sides, and we end up with the side TS being the following. Just about 8.1396. And so now that we have the last side, we can now work with the sine rule with the pairs. And so here we're going to have the first pair, which is this one here. So that is going to be 7.64 divided by sine. We will call it S because it is the angle that is in here, equals 8.1396 divided by sine 90, which would be this pair with that. So the two pairs we're working with are the two lines that are currently drawn. So we're going to go ahead and solve for sine S. So we end up with 7.64 times sine 90 equals 8.1396 times sine S. And so in order to get S alone, we first need to divide by 8.1396 to both sides. Here we get rid of the first one over there, of those two numbers. We end up with only sine S on one side. And what you do from this position on forward is that you need to get S alone, but since S is next to the sine, you actually need to apply this thing called sine inverse. And sine inverse gets rid of the sine. And if I have sine inverse on the other side, it's going to look like this. We do sine inverse to the whole thing. When that occurs, we end up with S equals something. And that something is going to be this whole number here. Okay, so we plug that into our calculator. We end up with the size of the angle RST being 69.8794. So this is the size of the angle RST. And that is for part C, by the way, not part B, is how you solve this problem. I hope it helped, and peace.